In this video, I just wanted to do an example of how to do the linear regression re-expression of the data in your calculator. So here we have an example where we have data from the amount of mortgages at a bank. So that data is given there, and I already have the data in my calculator. So if you're following along, you might want to take a second and get the data into your L1 and L2. Once the data's in, remember we can look at the original scatter plot by just doing a scatter plot on our calculator using L1 and L2 because that's where my data is. Remember, you're going to do a zoom 9 to get that graph there. Then remember, we're going to do the linear regression analysis. So we're going to do stat calc and do linear regression again using L1 and L2. And we get our analysis. Our R value is about 0.929, so not too bad. Then, of course, we want to take a look at the residual plot. Just a quick review of how to make the residual plot. Remember, go back to your stat plots, and then you're going to change your Y list to the resid list instead of your data list. So a second stat button, and then go find your resid list in there. And then again, do the zoom 9. So we can see from this residual plot that we definitely have a pattern in there, so there's probably a better model. What I'm going to do is try to re-express this data. This data appears to be exponential growth to me, so I'm going to try using a log re-expression. So what I'm going to do is go back to my list in my calculator, and I'm going to go to my L3 list, and I'm going to put my cursor up on top of that L3. I'm going to try to take the natural log of this list too. So I'm going to do a re-expression using the natural log of my Y values. You can use log or natural log, it really doesn't matter. So I'm going to do the natural log of list 2. So I'm going to type that up onto my L3, and then remember, if you just press enter, that will populate the whole list for you. So that's giving me my list 1, my list 2, and now my list 3 in my calculator. So now I'm going to just redo the process that we did up here with the new data. So I'm going to look at my scatter plot of the new data. So I'm going to look at the scatter plot using list 1 and list 3. And you can see that the data has straightened out a little bit compared to the original data, which definitely had some curvature in it. Then I'm going to do my linear regression with my L1 and L3. So just changing my list in here to list 3. Gives us the output. My R value is now 0.997, so definitely an improvement from what we had before, although our R value before was not a bad R value. But we have improved that, and then we want to look at that residual plot, of course. So I'm going to go back to my scatter plot, and I'm going to change my Y list in here to be my residual list. Remember, the residual list is repopulated every time you do a linear regression in the calculator. And then we can see that this residual plot has much less pattern in it than the original residual plot. So this looks like it's going to be our model that we're going to use. So this question asks us to find the most appropriate model. We're going to predict the mortgage for 2000, and then we're going to find the residual from that. What we need to remember when we write our equation is that we use the natural log of the Y variable, and that Y variable was the mortgage. Okay, so then my regression equation is going to be the natural log of the predicted mortgage value is equal to, and then pulling numbers from the calculator output, we get negative 353.79 plus 0.18 times the year. Question also asked us to predict the mortgages value that would happen in the year 2000. So remember, with the natural log in there, I'm going to plug in the 2000, and we'll end up with the value of 497.70. I assume that's in millions of dollars, but I forgot to put that in the problem. I apologize. Part C also asks us to find the residual, and it said the actual value was 49.7. So doing actual minus predicted, we get a residual of negative 448. So this is another example of the fact that this is an extrapolated value. The 2000 is considerably outside our data range, which our X values end in 1988. So this is an extrapolated value, and we should be very cautious of this prediction because it assumes the model continues, and that may not be the case.